Welcome to MATLAB tutorials, brought to you by Engineerise.com, where we engineer your rise. This week, we'll learn how to create graphical user interfaces and how to plot graphs in MATLAB. Graphical User Interface, or GUI, is an interface where the user can interact with the system graphically. That is, by using a mouse to click and point objects. In MATLAB, GUI is created using guide. You can open guide by typing its name in the command window or by clicking New Graphical User Interface. The guide quick start opens with various options for creating GUIs or opening previous ones. We'll start with a blank GUI. It opens to a window with a white space, that is our workspace. You can change the area as required. On the left, you can see a lot of buttons. These are the objects you can use in your GUI. Since we don't yet know them, let's change our preference to display their names. So we'll create a GUI corresponding to question number 5 of assignment 1. It's based on projectile motion with two inputs. Inputs are taken by edit text here. So one for projection velocity, another for projection angle. We'll put a push button here for the user to click. There are three outputs to show, which are given by static text here. So one for time of travel, one for maximum height, and another for range. Each of these objects have certain properties. Double clicking this opens the property inspector. Scroll down to find the property string. This is the text that shows here. Let's change it to projection velocity in feet per second. There's another property, tag, which is basically the name of the object. Let's make it velocity. I'll make similar changes to all the objects. Now that we're done, let's save it by the name projectile. In the current folder, you can see two files. Projectile.fig is the GUI, as the user will see it. Projectile.m is the code according to which the GUI will run. Let's run this. Right now it does nothing because we haven't told it what to do. The properties of each object here is accessed through a structure called handles. Each object that can take input has a callback function within the code. Now the idea is when the user clicks compute, it will fetch the values entered in this and then calculate and display the outputs. For this, we'll have to edit the function for the button. Right click, view callbacks, callback. Here we can write the commands it will execute when the compute button is clicked. First we have to get whatever the user has typed in the velocity box. So get, the properties are stored in handles dot, the tag that is velocity, property name that is string within quotes. We'll assign this to a variable vs. Whatever we get using get function is in the form of string. So we'll have to convert it to numerical form using string to num function and assign it to v. Next we'll get the angle. As equals get handles.angle, comma, string. This will get the value of string property stored in the angle part of handles structure. Like previous one, we'll also have to convert this to number. We already know the value of g, so we'll use the formulas to calculate time of travel, maximum height and range. Next step is to display the values. For this we'll use the set function. Set handles.tmax, string, t. This will set the value of property string of tmax object that is within handle structure as t. But the argument here must be a string. Similarly, for the objects ageMax and range. Let's save it and try this. We'll replace this with 600 and this with 54 degrees and compute. Here we have the results. Well, that's a basic GUI. You can make it more user-friendly and useful with various components available. We'll stop here and move on to plotting graphs. The simplest command to plot a graph is plot x, y. Here x and y are two vectors of same length representing x and y coordinates of various points on the graph. The graph is created by connecting these points. Let's plot a graph for sin x. First, let's create the vector x from minus 2 pi to 2 pi with elements at intervals of 0.5. Then plot x, sin x. You can see that the graph is basically made of lines connecting the given points. We'll reduce the interval to 0.1 and plot again. This time the plot looks smoother, but if you zoom in closer, it is still made of lines connecting the given points. Let's plot another function. T ranges from minus pi by 8 to pi by 8 and we'll calculate y beforehand. Remember to use element by element operations. Now we can make different improvements to this by using plot tools. Here is the icon to show and hide plot tools, or you could open it by typing plot tools in the command window. Let's put some grids to make the graph more readable. Let's change x label to angle in radians and y label to cosec x. You can change the limits of the graph here. In cases where you need to plot semilog or log-log graphs, you can change it here accordingly. Now, let's import some data from an external source, say an Excel sheet. All the numeric data is already selected, although you may change the selection if required. Each column will be saved as a vector. The new vectors to which the data will be assigned are these. Click on this one and the data has been imported. Let's look at a new way to plot. Select the variables to plot in the workspace by pressing Ctrl and switch to Plot tab. You can see the various options are active here. Click on Plot and here's the graph. Open Plot Tools and click on the line. You'll find various options to change the line style and markers. So I'm gonna select diamond markers of red color and no line. Let's say I know the theoretical function and I want to compare them on the same graph. So I'll save a variable with the range of the data and add data. The x data source will be the range I just created and the y data will be according to my theoretical formula. And here you can see the two plots on the same graph. You can insert a legend to specify which one is which. Once you are done with the plotting and formatting, You can save the figure as .fig or other formats as required. So this was all about 2D line plots in MATLAB. There is a long list of graphs and charts that can be created using MATLAB. You can find information about them in the catalog here, or look them up in the documentation. This week up to here. Thank you.